Okay, let's resume the class. You have the worksheet. Please turn to this worksheet, which I'm going to do a screen share here. Okay. So in diagram 1, M is here. The spring is being compressed. In diagram 2 shows how object M moved in the direction indicated by the arrow when object N was brought near. So you see it is being extended, right? So what is this cause? So again, you can key in your answer for me to check the answer. So this is Q4, question 4. So what is the answer for this question? Q4. Okay, notice here when N is there, so it's going up. Okay, Zhixiong correct. Nathan correct. For the rest, Natalie correct. Okay, try. So answer is this. Okay, when object N was brought near to M, the potential energy of the spring is increased. Okay, potential energy is increased. Because the rest, the answers are wrong. Okay, magnetic force of repulsion exists between this. So it's not repulsion. So this one confirmed wrong. Okay. Andre, you don't have the worksheet. I sent to the chat group already. Then I send to you privately if you don't have. So this one, you found the worksheet already? Andre. This worksheet I have sent to the chat group. So you take note. Okay, let me do a quick one since you don't have the worksheet. Energy. So this is energy MCQ and OEQ set 2. You can download now, those who don't have the worksheet. I'll resend to everybody just in case. Okay, this is the worksheet I just sent. Okay, magnetic force can stop the gravitation, so this is wrong also. Potential energy of object M decreased when M was brought near. Okay, this potential, because it's going higher, right? So it's the gravitational potential. So this is wrong. So it's not decreased, it's increased. Okay. When object N was brought to it, the potential energy of the spring increased because it's being stretched further. So answer is 3. Okay, next, number 5. Okay, number 5, we try to do this question because they are testing you, right? Which one shows the possible amount of potential energy and kinetic energy when the ball moves from X to Z? So you must be able to understand. So at this position, right, the kinetic energy should be 0, right? K should be 0 because it's not moving. At Y, the K should be maximum. At Z, there is KE and PE, okay? Because it is moving. Okay? But did they say exact they stop? Okay, it may stop exact, but it didn't say here. Because some of the kinetic energy is lost to the frictional force as it moves down. So what do you think is the answer? You try this one, everyone. Question 5. What is the answer? Okay, point X. Okay, Natalie correct. Zhixiong correct. Okay, Jing Nyok correct. Okay, so answer is 2. Okay, why is it 2? Because I told you, right? At this part, it's not moving, so KE is 0. Potential energy is maximum, so these two satisfied. Okay. At point Y, because this is moving the fastest. Okay, so 45 and 0. Okay, 0 is because it's not above the ground, so that's why it's 0 potential energy. And then this part, Okay, from here we can deduce at point Z, the ball is still moving because there's a 16 unit. Okay, potential energy is 21, it's above the ground. So 2 is the best answer. Okay, next question. This is an experimental based question. So Ali made 3 air guns. You can see here this one. And identical spring. So you highlight this identical spring. But each with a different length barrel. Length barrel is this part, the barrel of the gun. Okay, length barrel. So when he removed the key, because when he removed the key, the spring will spring outwards. Okay, remove the key. The compressed spring would push the pellet out of the gun barrel. So there's a pellet there that will fire forward. The experiment was carried out in an enclosed area without any wind. For each try, he measured the distance traveled. So you notice a pattern here, right? The pattern is as the gun barrel increases, right? Can you see the distance all increases? So there's one observation. You can write down this one. Okay. So they say for each of the try of the same gun barrel, the distance traveled by the pellet is different. Give 2 possible reasons. Okay, what they mean is, okay, you must read this way. They say for the same gun barrel. So you observe here, let's say for this one, right? For this one is this gun barrel. Why is these 3 answers different? What they mean is, why are these 3 answers different? So they ask you give 2 possible reasons. Okay, notice the second one also the same thing. Let's say you see this one, right? Why are these 3 values different? 163, 169, and 171, although they use the same gun barrel. Okay, so they say give 2 possible reasons. Okay, as long as your reason is reasonable, it can be accepted. So you can talk about the angle they fire, right? Maybe it's not parallel to the ground. Okay, so there's one possible reason. This question 1. Or I can say that Ali shot the gun at different height, because if you raise slightly higher, it release at a higher point, it will reach further distance. So there are these 2 possible reasons. Okay, these 2 possible reasons. Either number 1, I put it here. Okay, so reason number 1, okay, I combine everything together. You just put it inside. Okay, there are 2 reasons. So reason number 1, okay, Ali shot the air gun at different height from the ground for each try. Okay. Reason number 2, you can put here. Ali shot the gun at different angle from the ground for each try. So this will result, even the same gun barrel, we have 3 different values. Okay. So these are the possible reasons. Okay. So you take note of that. I will screenshot this for you to take note and notate. Screenshot. Okay, next question. How is the distance traveled by a pellet affected by length of gun barrel, which I told you the reason earlier, right? So as the length of the gun barrel increases, distance traveled by the pellet increases. Okay, so this is very simple, short and sweet. Okay, as the length of the gun barrel increases, the distance traveled by the pellet also increase. Simple. Okay, I will send this to you for your reference. Screenshot. Download. Okay. Okay, next question. We'll proceed to the next question. So we get it correct. Okay, next I need to show you this, the largest wind farm. So you need to appreciate this conversion of kinetic energy from the wind to produce electrical energy. So sit back and relax as I show you the largest wind farm in the world.
Looks like a giant construction set, just waiting to be assembled. Because that's exactly what it is. From this base in Hull, steel towers, fiberglass blades, and all-important turbines are being bolted together 75 miles out to sea to make the world's largest offshore wind farm.
So these sections are the top third of the tower. This is the thinnest bit. It's narrowed up from 8 meters at the bottom through to here at the top.
Just a week after the first turbine components left port, it was assembled and generating electricity.
So this part is the largest wind farm. It's offshore. Offshore means not on land. Because at the sea, the wind velocity is much higher, so they build offshore.
The scale has transformed. We're now using much bigger turbines. We're now installing much bigger wind farms. We're also doing it further offshore. We've been able to do this for a much lower cost of electricity, and it's probably the best and lowest cost solution that we've got available to us.
The sheer size of these new wind turbines means just one rotation produces enough electricity to power a home for 24 hours.
They're quite amazing. What they estimate is just one rotation, they turn one round, right? They can produce electricity for a house for 24 hours. Okay, because of the tremendous energy produced. And this, they will show you the relative size of how big is this wind farm, this windmill here.
Each one is 154 meters across, meaning each blade is nearly as wide as the world's largest passenger plane.
So the world's largest passenger plane is an A380. So each blade is almost the same width as the world's largest passenger plane, 80 meters across.
And at 190 meters high, they dwarf.
And this is higher than the Singapore Bukit Timah Hill, 190 meters. Singapore Bukit Timah Hill is about 165 meters.
Central London's BT Tower. And bigger projects mean wind makes up a greater share of generation. Today, for example, a quarter of our electricity came from wind, compared to the next largest low-carbon source, nuclear, at just 15% and falling.
So you notice here, this one is that in that country, they produce a lot of renewable energy, wind, 25%, and that country also has nuclear power. So there's one nuclear power
source, nuclear at just
15.3%.
15% and falling. And unlike nuclear, scale means the cost of wind power is coming down. This factory in Hull makes the turbine blades. Each one of these blades is 75 meters long, and they've effectively been handcrafted out of balsa wood and fiberglass. And they've had to make 522 of them at this facility for the Hornsey 1 project.
The industry is definitely scaling up. So we're more or less at our full manufacturing rate for this size of blade. So, you know, real securing the jobs of the 1,000 people that work here. In the summer, we'll be moving on to the next blade type, so the 81 metre, which is even bigger again, and that's for the Hornsey 2 project.
All right, Howard. Yeah.
The success of offshore wind isn't some sort of industrial miracle. We paid for it. UK energy customers will hand over more than £4 billion in subsidy to Hornsey 1. But the cost of the next phase, Hornsey 2, is coming in at half that. It's unlikely turbines like this will ever meet all our electricity needs all the time, but the wind is on the way to becoming the dominant force in our power sector for decades to come. Tom Clark, News at 10.
So this is a video, the world's largest wind farm. You can read out more about this. It's called the Hornsey project. I think it's in Norway. Yeah. So that's the largest wind farm. Let's continue our question here. So this one, fill the blank to show the energy change. So it's quite easy, right? So for that power is, wind is moving air, right? So it has kinetic energy, correct? So for this one, is KE, kinetic energy in the wind. Okay, this one you just because they put the energy below. So you just spell kinetic. Okay. Kinetic. And this one also kinetic. And this is electrical. Okay. So kinetic, kinetic, electrical. Okay, next they say, in this situation, this turbine, right? Q, this is P, again, this is P. So you know this is turbine P, this is turbine Q. Okay, they say that both wind turbines P and Q have the same length of blades. So just now we saw that the blade was very long, like 80 meters, and of different materials. Okay, so both are built in the same location. It is found that the amount of electricity produced by wind turbine Q more than wind turbine P. So they ask you to explain this observation. So this question, you know, is actually related to this energy conversion. So in order to get more of this, right, more electrical energy, I must have more of this. So how do I have more of this? Okay, because the wind is fixed, the wind velocity is fixed. So in order to have more of this, that means the blade must rotate faster, right? So how to rotate faster? Okay, do you think a lighter blade will rotate faster or a heavier blade? Okay, with the same energy, right? With the same kinetic energy, a lighter blade will rotate faster, right? So we should explain by saying the mass of wind turbine Q, right, could be less than that of wind turbine P. Therefore, with the same amount of kinetic energy, from the wind, right, the wind turbine that is lighter will rotate faster, thus producing more kinetic energy, which will be converted to more electrical energy. So that's the thinking process behind this. So I will put the answer in this section here. Okay, I put it this way, easier to see. Make it bigger. So you explain by saying the mass of the blades of wind turbine Q could be less than that of wind turbine P. Maybe I leave a space here. Therefore, when the same amount of kinetic energy from the wind is transferred to both wind turbines P and Q, wind turbine Q will rotate faster because it's lighter. So because the same kinetic energy from the wind, a lighter blade will turn faster. By turning faster, it will produce more electrical energy. Okay, so this is the thinking process behind this. I will screenshot this and send to you all shortly. Okay, very good. Save this and send. Okay, I think sooner, maybe 7 to 10 years time, Singapore may build windmill if we have mastered the technology. Okay, now Singapore government depends a lot of solar energy. You can see HDB flats on top have solar cells. Okay. Okay, next question. We have about 10 minutes left. Okay, this question, if I notice, I think it appears in some of the year's PSLE paper. Okay, so this is a twisted rubber band. There's a feathers there. So it says that a pair of feathers was joined. This one, this feather, okay, with a rubber band. When the pair of feathers was turned several times, see the rubber band being twisted, right? That's means it stores elastic potential energy. Okay, upon release, the pair of feathers turn, rotate, and the toy flew upwards to a height. So they measure this height. So they release here. This is point of release. So imagine the person holding that and release the thing. So it fly slightly higher than drop down and form a dent here. Okay, this dent is actually caused by the impact. So if it drop from a greater height, the dent should be deeper. And if the toy is heavier or have a greater mass, the dent also will be deeper. Okay, state the energy conversion that takes place in the toy. So notice this is in the rubber band. So in the rubber band, obviously there is a what? Elastic potential energy. Okay. And then the energy in the pair of feathers, because it's rotating, right? So it's kinetic. Okay, in his second attempt, Joshua twisted the rubber band more times. So we highlight this word, more times. The toy created a bigger dent when it landed. So does it explain this observation? Okay, explain this observation. Okay, twisted more time means it can fly higher, right? Okay, so because of greater height, we have greater GPE. More GPE will be converted to more kinetic energy. So it would land with a greater impact because it dropped on a greater height. Okay, so for this question, you should mention about the rubber band had more elastic potential energy, which will be converted to more kinetic energy. Okay, the rubber band had more elastic potential energy to be converted to more kinetic energy in a pair of feathers. Therefore, it would land more kinetic energy. Okay, maybe I add in some point, allowing it to fly higher, allowing it to reach a greater height, a greater height. Therefore, it would land on the tray of plastic with a greater force of impact. It is part. Okay, so you fly higher, so you will impact with a greater force. Okay, next, the next question says, he replaced a pair of feathers with but heavier feathers. You highlight this. Okay, heavier means it will increase GPE, right? Okay. So they said the toy flew to the same height. Before it dropped on the same tree, would the dent be the same, increase or decrease? So now it's use heavier feather, but they say they fly to the same height. So remember I told you, right? The GPE depends on the formula, right? GPE, remember? The formula is mass times gravity times height. So if it is heavier, it will have more GPE. So more GPE will convert to more KE. So it will have a greater, will have increased dent. The dent will be deeper. Okay, so they ask you this one. Would it be the same? So answer is increase. Okay, would it remain the same, increase or decrease? So answer is increase. So this is the answer. You can write down. The pair of heavier feathers had more gravitational potential energy than a pair of lighter feathers when they were released from the same height. As a result, it had more kinetic energy to exert a greater force of impact on the plasticine. Okay, so I save this and send the screenshot to you, every one of you, for you to refer to the model answer. Okay, we have 5 minutes left. Hopefully can finish everything on time. Okay, this is a hydroelectric power station. You can visit the YouTube and key in hydroelectric power generation. Okay, if you print out your worksheet, you may not be able to see the X and Y. So I highlighted here, I put in the white color X here. So the energy at point X is very simple because it's at a height, right? So this is gravitational potential energy. Okay, energy at point Y, this part is flowing fast, so it's kinetic energy or water. At generator is electrical. Okay, so this energy conversion. Okay, state one advantage of using hydroelectric power station to produce electricity. Okay, in fact, there are several advantages. Number one is renewable. Number two is it does not produce pollution. It's pollution free. Okay. Okay, some of you are learning the topic on global warming, right? So carbon dioxide is a greenhouse gas. So one advantage is hydroelectric power station will not produce any greenhouse gases, okay, which is carbon dioxide that leads to global warming. So any of this, or you can say running water is a renewable source of energy. Okay. Okay, next one. This part. This shows the amount of rainfall collected. Okay, let me save this further. Amount of rainfall collected in location P, and this one is location Q, and this is location R. Okay, you see this is more constant, right? Amount of rainfall. So we take note, because for hydroelectric power station to work well, the maximum amount of water should be stored here. So this question asks you, this question, let's scroll down. Which location, P, Q, or R, is the most likely place? So I've already given you the hint, right? Of course, it's P, because the amount of rainfall is constant throughout the whole year. I don't want my dam got no water. Okay, so the dam should have maximum storage. So it's location P. Okay, then you need to explain your choice. So you should say that it received the highest amount of rainfall throughout the whole year. Therefore, the reservoir, right, will have a consistent large amount of water that allow the water to flow through to turn the turbine to activate the generator. Okay, let me share you the answer to this part. Okay, let me paste it here. Okay, so this is the answer. Okay, maybe I put it here. The line blocking. Okay, P, location P, it receives high amounts of rainfall throughout the year. Therefore, the reservoir has a consistent large amount of water that allows water to flow through to turn the turbine to activate the generator. Okay, you take down the answer. I will send this to you now, plus the previous one. Okay, then with some minutes left, I try to show you the HEP. Hydroelectric power plant. This one some of you have seen before, so just a quick sharing for some of those who have not seen. Okay, this is a hydroelectric power plant. Sit back and relax.
$170,000 cubic meters of water flow past here every minute at almost 60 kilometers per hour. That's enough water to fill about 100,000 Olympic swimming pools every day. Standing here, you can actually feel the power of the water. Harnessing that power is what hydroelectric stations have been designed to do for over 100 years in Ontario. In essence, they are factories that convert the energy of falling water into the flow of electrons, or what is commonly called electricity, the electricity that powers the province.
So you notice this is the dam is actually very high. So the reservoir is being blocked by this structure here, which is easily about, I think the length, 300 meters across. And the height from the drop is about 50 meters. Actually, they dam out the part of the Niagara River.
Most hydroelectric stations use either water diverted around the natural drop of a river, such as a waterfall or rapids, or a dam is built across a river to raise the water level and provide the drop needed to create a driving force. Water at the higher level is collected in the forebay.
So this part, the large amount of water, due to the high rainfall, right, So it stores at gravitational potential energy. So as it rushes through from a great height, right? So the kinetic energy of the water will increase.
It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level.
So as the kinetic energy of the water turns the turbine, so you see this part, there are actually many permanent magnets spinning. As they spin round the copper wire, right, it produces electricity.
At the lower water level, the water pressure increases as it flows down the penstock. It is this pressure and flow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnets are attached to the rotor located within coils of copper wire called a stator. As the generator rotor spins the magnets, a flow of electrons is created in the coils of the stator. This produces electricity that can be stepped up in voltage through the station transformers and sent across transmission lines.
So this is how hydroelectric power station produce electricity. So GPE of water change to kinetic energy of water, change to kinetic energy of turbine, change to electrical energy. So I've finished today's lesson. I need you all to turn on your video for attendance taking. Okay, so you all turn on your video first.